Students, in this video, we have to calculate the electric potential due to electric dipole at any point, neither along axis of the dipole nor broadside on position or equatorial position of the dipole. We have to find any point inside the electric field of this electric dipole. Let this point is P, and now we have to find the electric potential at point P due to this electric dipole. So firstly we have to join the point P from point B, and also have to join the point P from point A. Let this distance, means the distance of this point from minus Q charge is R1, and the distance of this point from plus Q charge is R2. Let this O is the center point of this electric dipole. So we have also joined the center of this electric dipole with this observation point P. Let the angle subtended by this OP with AB is theta, okay, and the distance of this point from point O is R1, okay. Now we know that the electric dipole is very small, like that HCl, H2SO4, H2O. These are the molecules. So the size of the molecule is very small. That's why this distance is very small. Okay. So the distance AO will also be very small. So we can say that this distance R and R2 are approximately equal, or the distance AP and OP will approximately parallel. So this angle will also be theta. Okay. Now draw a perpendicular on this AP side from this point B. This is the perpendicular. Let this is point N, this one point is N. This angle will be 90 degree. Now look at this. This R2 means BP, and the distance R1 AP. Okay, these distances are very greater than that of this distance. This distance is at very far from these points. Okay. Now we can say that the distance, these lines means BP and AP will approximately perpendicular, we imagine, to find the electric potential. Okay. Now the difference of the distance from point B and from point A of point P will be this one, AN. Okay, this one is greater than that of R2. That's why the difference will be R1 minus R2. So this will be R1 minus R2. This is the difference between two distances, R1 and R2. Okay. Now this is the triangle. Now we have to find the electric potential at point P. So due to the plus Q charge, electric potential at point P will be V1 equal 1 upon 4 pi epsilon naught plus Q upon distance. What is the distance here? R2. Okay. Now the distance we can write here first Bp, and then V1 equal 1 upon 4 pi epsilon naught plus Q upon R2, equation first. Now the electric potential at point P due to minus Q charge will be V2 equal 1 upon 4 pi epsilon naught minus Q upon R1, the distance of P from edge R1. Let the dielectric constant of this medium where electric dipole is placed is K, a dielectric constant of the medium. So here also be K, here also be K, or V2 will be equal R1. Firstly we have to write AP, and then 1 upon 4 pi epsilon naught minus Q upon R1. This one is equation second. Now we know that the electric potential is the scalar quantity. So V1 and V2 also will scalar quantity. So the total or the net electric potential at point P due to these charges will be the algebraic sum of V1 and V2. So the algebraic sum is V equal V1 plus V2. On putting the value of V1 and V2 from equation first and equation second, we get V equal 1 upon 4 pi epsilon naught plus Q upon R2 and plus 1 upon 4 pi epsilon naught minus Q upon R1. On taking the common Q and 4 pi epsilon naught, and here K also. So Q upon 4 pi epsilon naught K inside the bracket 1 upon R2 minus 1 upon R1. This is the remaining part. So V will be equal to Q upon 4 pi epsilon naught K. On solving this part, it will be the LCM of R1 and R2 will be R1 and R2, R1 into R2, and the cross multiply of 1 and R1 will be R1. Here minus is there, and the cross multiplication of 1 and R2 will be R2. Okay, so this is the equation. Now, or V will be equal Q upon 4 pi epsilon naught K. Listen, R1 minus R2 is equal to AN. Okay, now and the R1 and R1 into R2, we have to find the value of these firstly. So what will be the value of R1 minus R2 and R1 R2? So from this triangle, this right angled triangle A and B, in triangle A and B, cos theta will be base upon hypotenuse, and base here, this is the base, this is perpendicular, and this is hypotenuse of this triangle. So the base will be AN, see, equal AN, and hypotenuse AB, AN equal cos theta, AN equal AB cos theta, AN equal R1 minus R2, AB equal 2L and cos theta, AB equal 2L and cos theta. Now again, point B and point A are very close to each other because this is the electric dipole like that HCl, H2SO4, NH4Cl. These are these are molecules, and the size of molecule is very small. That's why we can say that these are very close to each other. Okay, and this R1 distance is very greater than this 12 distance, and R2 distance is also greater than 12 distance. So we can say that R1 is approximately equal to the R2. R1 is approximately equal to the R2, and it is equal to R. Okay, let. So the R1 into R2 will be R into R equal R square. Okay. Now, on putting the value of R1 minus R2 and R2 minus R1 into R2 in this equation, let this equation is third equation. So potential V will be equal Q upon 4 pi epsilon naught R1 minus R2 equal 2L cos theta upon R1 into R2 equal R square. Okay. Now we know that Q into 2L equal P. This is the dipole moment. Now the V will be equal 1 upon 4 pi epsilon naught, here K also, then this will be equal to P into cos theta upon R square. This is the equation. This is equation 4th. Okay. Now in air or in vacuum, K is equal to 1. Okay, this dielectric constant is equal to 1 for air or vacuum. So this equation will become V equal 1 upon 4 pi epsilon naught, and here P cos theta upon R square. This is the electric potential at this point due to this electric dipole. Now we can say about the specific cases about this this equation, this fifth equation. So the special cases, first, if theta equal 0 degree, that one theta equal 0 degree means if this theta will 0 means this point will shift like that, and this OP will parallel to the axis of this electric dipole. This will shift along this direction means this is along the axial position of the electric dipole. So the V will be equal 1 upon 4 pi epsilon naught and P cos 0 degree upon R square, or 1 upon 4 pi epsilon naught P into 1. P into 1 means P upon R square. This is the formula of electric potential at axial position of the electric dipole. Now second case, if theta equal 90 degree, then V will be from this equation 1 upon 4 pi epsilon naught P cos 90 degree upon R square. Cos 90 degree means 0. Then it will equal to 0 because P into 0 equal 0, and 0 into 1 upon 4 pi epsilon naught equal also be 0. That's why the potential will be 0 where theta equal 90 degree means this OP line will shift along this direction towards this direction. So at this condition, theta will 90 degree. At the 90 degree, the point P will be at the broadside on position or the equatorial position. Okay, so we had already studied that the n and at the point on equatorial position, electric potential is 0. So this is also verify that one. This is completed. Okay, thanks, Vita.